Good morning, my friends in Colombia. I'm Ken Ho from Hong Kong. It's my great honor to be invited to participate in this seminar. I'm sorry that I cannot be with you in person. The paper that I'm going to present today is entitled Holistic Management of Landslide Risk, which is co-authored with my ex-colleague, Ms. Carrie Zhang. I'll be addressing 5 topics in this presentation. These are portfolio landslide risk management, systems framework for holistic risk management, strategies for managing urban slopes and rural slopes respectively, the role of technology and data, and finally, effect of climate change on landslide risk. As I have retired since the early part of this year, I can now look back over my working career and share with you my experience and pragmatic views, both as a practitioner and as a risk manager. First of all, let's look at portfolio landslide risk management. In the keynote paper for the 13th International Symposium on Landslides, ISL, held in Colombia last year, I highlighted a range of problems associated with human fallacies in the context of landslides, together with some of the key challenges faced in the practice of landslide risk management in the real world. Risk is equal to the product of the probability of failure and the consequence of failure. Inappropriate human activities can escalate the chance of slope failure or exacerbate the consequence of a landslide, hence increasing the landslide risk. Risk can be managed using measures to either address the former or the latter or both. As far as a government or slope owner is concerned, the risks posed by the entire portfolio of slopes to the affected community should be managed under an appropriate disaster risk management regime and governance in order to properly discharge one's due diligence. In the context of landslide risk management, there are a number of key stakeholders, namely geotechnical professionals providing technical input, 2, safety risk managers and regulators. They set up and steer the governance of the slope safety system and coordinate input from technical experts as well as from social science experts. 3, policymakers. They endorse policy proposals and allocate financial and human resources. 4, general public, who are the risk bearers. Close collaboration amongst the various key stakeholders is of vital importance. From the governance perspective, a multi-pronged systems approach has proven to be the most effective means in managing the landslide risk posed to the community. For example, the Geotechnical Engineering Office of the Hong Kong government takes up the central role with 3 hats on, namely 1, as a safety system manager, 2, as a regulator with policing and gatekeeping functions, and 3, as a service, information, and public education provider. The state-of-the-art involves the adoption of a holistic or integrated systems approach in managing landslide risk in totality. It should be noted that each country or city has to tailor-make its own landslide risk management system to best suit the local challenges and constraints. Second topic, systems framework for holistic landslide risk management. Ideally, a risk management system should comprise both top-down approaches, for example, legislation-empowered authority for gatekeeping and auditing purposes, or formulation of risk management policies and plans, assignment of slope maintenance responsibilities, etc., as well as bottom-up approaches, which may include the promotion of community participation capacity building, and empowerment of local village representatives as sub-safety champions, and tapping the wisdom of the indigenous population. These are, of course, to be applied in different proportions that best fit a given district or community. This slide shows the first steps of a risk-based systems design. System managers, who are usually professional engineers under the governance, are tasked with identifying the problems, together with formulating solutions and prioritizing them. The keys during this stage are quality data, technical competence, and risk-based thinking. With limited resources, one has to be satisfied with prioritizing solutions and ensuring an appropriate scope of application in terms of coverage. There should be forward-looking roadmaps with a sound scientific basis. When it comes to resources allocation, it involves selling and explaining policy proposals to the policymakers so that they're willing to invest in order to address the future uncertainties. In practice, there are two pragmatic approaches. Number one, input by local technical experts, possibly in association with learned societies, to engage the policymakers in such a way that they appreciate the nature and scale of the problem, as well as the importance and urgency of allocating funding resources relative to other needs which they have to balance against, as resources will always be limited. Number two, an alternative approach is to engage additional expert support from the international front, for example, in the form of a review board or expert panel, given that the independent and impartial advice could be more convincing to the policymakers. Let me now illustrate the key landslide risk management strategies adopted in Hong Kong, which are the foundations for the corresponding sub-safety policies. This figure depicts the notional landslide risk trend plotted against time. The setting up of the GEO in 1977 was a turning point, and landslide risk has been reduced substantially with time since then. The key strategies adopted to manage landslide risks are threefold. Firstly, to contain the risk from new development in order to freeze the problem, so to speak. This is done during the land use planning stage, as well as during the design and construction stages. Number two, to reduce the risk posed by existing developments. This is done primarily using engineering measures under systematic programs. Number three, to minimize landslide consequences. This is done through a variety of resilience or non-engineering measures, such as the landslip warning system, squatter clearance program, public education, etc. In the forensic investigation of landslide disasters, one should not just focus on the technical aspects, but should also consider the risk management perspective in terms of the root causes of the disasters. The time window of opportunity for putting forward a new crisis-driven public safety policy is usually very short, bearing in mind the time needed to deal with numerous urgent tasks during the rescue, remedial, and recovery phases. However, one should try his best to capitalize on the event and ride on the lessons, whilst memories are still fresh on the citizens' and politicians' minds. Hong Kong experienced a series of landslide disasters in the 1970s, which caused public outcry, and a panel of international experts engaged in the forensic investigation recommended the establishment of a central body responsible for sub-safety. This culminated in the establishment of the GEO and the implementation of a comprehensive sub-safety system, which has paid dividends in improving public safety. Traditionally, the effective safety of a slope is assessed by stability calculations, which is standard textbook material. This type of assessment is done at the scale of an individual slope and is more suited to the stability assessment of specific slopes in engineering projects. The risk-based approach, on the other hand, provides a much broader perspective and additional insight in respect of landslide risk management. Whilst it can also be applied to an individual slope, the latter approach can quantify the risk level and evaluate the risk profile of a group of slopes, which can provide a rational basis for policy setting and consideration of resources allocation. A paradigm shift and technical advances are needed to develop a suitable risk management approach for landslide problems, which was actually done in Hong Kong previously. It should be noted that the traditional soil mechanics approach and the risk management approach are complementary in practice. The system implemented in Hong Kong places emphasis on the application of modern geotechnology, capitalizing on advances and innovations made in focused technical development work, to the legislative and administrative frameworks which provide the authority and mandate. A wide range of resilience measures are also implemented in Hong Kong to reduce the consequence and damage in the event of landslides. In essence, the general public have an important role to play in managing landslide risk in a holistic manner. One way to assess the effectiveness of a sub-safety system is to gauge the public pulse. For example, we in Hong Kong have engaged a third-party research organization to carry out public opinion surveys on a yearly basis by means of phone interviews. This provides evidence for the public's general satisfaction or otherwise with the sub-safety system and its outcome. The outcome being reduction in landslide fatalities and damage. However, the recent findings suggest that general public in Hong Kong are becoming progressively more complacent about landslide risk. This is of concern to us, particularly in the face of the emerging risks associated with climate change. Regarding the question of willingness to invest, it is important to realize that the reactive or post-disaster remedial approach will be more expensive and more damaging to the community, in particular for fatal landslides involving massive fatalities, as these are liable to lead to a tsunami of political and socio-economic crises. The Sendai Framework for Disaster Risk Reduction 2015 to 2030, promoted by the United Nations, provides comprehensive advice and guiding principles on the priorities for action at local, national, regional, and global levels. It also outlines the specific roles and responsibilities of different stakeholders, from leaders to the underprivileged, in terms of their commitment, knowledge, and resources. In setting up a new safety risk management system, this is one of the go-to reference documents. It is noteworthy that the comprehensive sub-safety system in Hong Kong turns out to be well aligned with the Sendai framework, which is reassuring. Another relevant reference for the formulation of public safety policies is the World Health Organization framework, which is an instrument for gauging the maturity level of a country in terms of health performance. This provides guidance on the focus at each stage of the system's development. This could be helpful to a country in prioritizing their needs when customizing other countries' experiences for their application. Suffice to say, by cross-referencing other relevant experiences, one could instigate smart knowledge and technology transfer, targeting major subhazards and taking due account of local conditions. In our experience, quality and fit-for-purpose public safety policies should have the following characteristics. Number 1, transparent and defensible. Number 2, rational and reliable. Number 3, people-centric. 4, holistic. And finally, outcome-focused. The outcome in the present context is risk reduction. The paper elaborates on the discussion on these points. Of course, we all face the challenge of having limited resources. A key question we need to ask ourselves is how to maximize benefits from the available resources. Going forward, there may be more opportunities for subsuming disaster risk reduction measures under adaptation or resilience programs for climate change. So, what are the secrets of success of a systems approach? In our experience, these include the following. First, each system component or subsystem should correspond to specific hazards and with appropriate risk-based targets. Secondly, it should be scalable. In other words, a suitable balance should be struck between the scope of coverage in terms of risk-based priority, together with resources input and public expectations. 3, it should be measurable, in particular with respect to risk-based targets, and it should be traceable. And 4, it should be able to articulate a continuous improvement mindset and culture. In practice, attention should also be directed to identifying systems defects and plugging the gaps as an ongoing process. In our keynote paper for the 13th ISL, International Symposium on Landslides, last year, I discussed 5 practical challenges in the implementation of landslide risk management practice based on collective experiences around the globe. These are namely 1, disconnect between policy and practice, 2, human inadequacy, 3, weak link between government steer and community-based approach, 4, importance of expert benchmarking, and 5, deficiency in risk communication. Now let's look at some potential ways or means to tackle these challenges from the perspective of governance. Firstly, we need to avoid complacency. It is vitally important to cultivate a community that is vigilant to the exposed risks and is well equipped in terms of crisis preparedness and resilience. 2, building a trademark. The success of a system hinges on public trust, which in turn comes from government's credibility in the subject. A positive professional image is related to visibility, which can be enhanced by partnering with the media and local key opinion leaders, together with capacity building in terms of professional upskilling. A successful trademark strategy can facilitate more effective policy implementation and help avoid a blame culture in the aftermath of landslide disasters. 3, being alert to changes in the risk environment. Changes may involve slope deterioration, urbanization causing changes in the risk profile, etc., that may increase the risk level, or changes in socioeconomic conditions which increase public expectations. For managing expectations, never overpromise. And remember, there's always a need to continue to improve on our skills in respect of risk communication with laymen. Right, let's move on to the next topic. From a risk management perspective, slopes in urban areas and in rural areas respectively are subject to different settings and constraints, which in turn call for different risk management strategies. This is Hong Kong, which is a densely urbanized city. Landslide risk, of course, only matters when landslides interact with the built environment. Such interaction is intense in the urban areas, and landslide hazard may be easily aggravated by human factors in the urban environment. In a congested, built-up area, even a relatively small landslide could lead to serious consequences to life and property. Urban development itself may result in the formation of potentially unstable slopes or even trigger landslides. There can also be severe space and access constraints for the implementation of engineering works on urban slopes. Therefore, tackling urban landslide problems requires a holistic risk management strategy, entailing the use of engineering as well as non-engineering approaches, including policy, legislative, administrative, technical, educational, community-based, and emergency preparedness provisions. The Hong Kong slope safety system is regarded as a role model for densely urbanized cities. Human settlements in rural areas or remote villages, particularly in a vast country, pose localized and dispersed risks in relation to landslides from natural terrain or substandard man-made slopes. For example, those formed as a result of illegal site formation works by the villagers. However, in a sizable rural village with a large cluster of village houses or squatter huts, the vulnerability could be high, as illustrated by the significant fatality figures in some of the notable landslide disasters, such as the Shaolin village disaster in Taiwan in 2009 and the recent Topo disasters in India in June this year, as illustrated on the slide. The challenges of tackling natural terrain landslide hazards lie with the prediction of landslide locations, scale, and characteristics, in particular, the landslide volume, entrainment potential, and runout distance, thickness, and velocity, so as to assess the likely impact on the affected community. The potential for low-frequency, large-magnitude landslides is also increasingly becoming a concern due to the impact of climate change. The most cost-effective way to tackle natural terrain landslide risk, particularly in a rural setting, is through land use planning. For example, avoiding the more risky areas by pre-identifying the more susceptible terrain, or to relocate existing settlements, particularly those associated with illegal occupation, away from vulnerable areas. If relocation is not feasible or strongly resisted, and where a sizable village is threatened by debris flow hazards from natural terrain, the risk mitigation concept would be more applicable, subject to the availability of resources, of course. For the smaller, isolated, man-made slope hazards, simple and localized slope improvement works, such as drainage improvement, and regular slope inspection and maintenance would be more conducive. In practice, the community-based approach is usually more appropriate for rural slopes. This includes, for example, the training of local representatives to keep a close watch of the slope condition at times of adverse weather, and the implementation of an early warning system and emergency evacuation plans in case of alarm, together with undertaking regular drills and educating the local villagers to take self-precautionary actions at times of heavy rainfall. And a good example of a fairly mature community-based approach is given by Taiwan. Here, the communities in the local villages are empowered to take actions in respect of hazard mitigation, crisis preparedness, and emergency response. A collaborative approach is taken to identify hazards, assess vulnerability of different areas, and map out suitable emergency evacuation routes in case of debris flows. Through a participatory process, community residents can obtain the requisite knowledge about hazardous and vulnerable conditions, and they can help to look out for signs of imminent failure and contribute to jointly formulating strategies and solutions. The above approach helps to promote co-ownership of the problem and cultivate a self-protection culture. Let's now move on to the topic of technology and data. In recent years, Hong Kong has been actively promoting the integration of modern technologies into geotechnical practice. These include the application of remote sensing technologies, which comprise satellite, airborne, land-based, or handheld tools, such as LiDAR and ISSAG. Digitalization of various design processes, adoption of artificial intelligence, AI, to identify landslide scars and slope hazards, application of machine learning tools to predict landslide susceptibility, use of robotics and drones to assist with landslide inspections and facilitate slope works projects. Further examples of applications of innovation and advanced technology include the use of novel materials such as self-compacting foam concrete to upgrade substandard loose-fill slopes, automation of laboratory testing in respect of cube testing and tensile tests of steel reinforcement, smart barriers which send real-time signals to emergency duty officers when debris impact is detected, etc. Other examples of integration of innovation and technology in geotechnical practice in Hong Kong include digital site supervision system, incorporating blockchain technology, common operational picture, which is a cross-departmental cloud GIS-based platform to facilitate timely sharing of emergency information for the formulation of contingency plans. Use of digital twins, a local community messaging system using LoRaWAN technology, which stands for Long Range, Low Power, Wide Area Network technology, for the dissemination of early warning messages for those villages threatened by landslide hazards. Apart from technology, data is also of the essence. There is an increasing amount of potentially useful data made available as open source, which could be put into gainful use. For example, the United Nations Office for Disaster Risk Reduction gives examples of open databases which contain free data and relevant parameters for broad brush landslide risk assessments. Similar tables are also made available for other forms of natural disasters. Another example is the GEO open data in Hong Kong, which includes the territory-wide LiDAR data and Lands Departments of the Hong Kong government open geospatial data. Various organizations around the globe are also starting to share their ground investigation data, including Hong Kong. The opening up of the data for public use is a worldwide trend and is consistent with the progressive development of smart cities. Other potentially useful online resources include the NASA Landslide Team projects. For example, the Landslide Hazard Assessment for Situational Awareness Model, the Global Landslide Model, the Global Landslide Susceptibility Map, Global Landslide Catalog of Cooperative Open Online Landslide Repository, etc. And also the Landslide blog promoted by Professor Dave Petley in the United Kingdom. It should be cautioned, however, that the users should be well aware of the data source, data resolution, as well as their applicability and limitations for specific use. My final discussion topic is climate change. There are grave concerns amongst the experts that extreme weather events associated with climate change could lead to a significant increase in landslide risk in certain situations. The Joint Technical Committee on Natural Slopes and Landslides, JTC1, coordinated the publication of a textbook, of which I was the lead co-author, in 2017, that contains country reports on the state of the art in climate modeling and projections of extreme weather, in particular extreme rainfall, together with the key challenges and state of sub-safety preparedness for climate change impact in a total of 21 countries or cities, including the discussion of novel tools and new initiatives that are being considered to assess and manage the corresponding landslide risk. In the last few years, we in Hong Kong has been putting in concerted efforts to gear up our sub-safety preparedness for the impact of climate change, details of which were consolidated in this invited paper, presented to the 5th World Landslide Forum in Osaka, Japan, 2 years ago. A brief summary of our initiatives and measures is given in our paper submitted to this seminar. This slide is based on actual data on the performance of different slope types in Hong Kong during a record-breaking rainfall event in 2008. It illustrates the importance of a proper understanding of the changes in the risk profile that can be brought about by extreme rainfall. Let me take you through. The top figure plots the number of landslides in a given area on both man-made slopes and natural terrain, respectively, when subjected to increasing rainfall. When the rolling 24-hour rainfall exceeds the threshold of about 20% of the mean annual rainfall at a given locality, natural terrain landslides would overtake man-made slopes as the principal landslide hazard in the form of debris flows or debris avalanches, many of which can be mobile with long run-out distances given adverse site settings under extreme rainfall. The corresponding shift in the risk profile and the exponential increase in the scale of the problem due to occurrence of extreme rainfall, as illustrated in the bottom figure, has profound implications on landslide risk management. Novel tools such as scenario-based assessment and stress testing, which were developed and applied in Hong Kong to assess the potential impact of extreme rainfall, compared against the capacity of the government's emergency response and rescue system. The exercise provided considerable insight on the scale, context, and uncertainties of the problems faced, together with the prudent strategies that we should consider. It is important to recognize that extreme rainfall events are liable to lead to the concurrent occurrence of multiple hazards, such as landslides, flash floods, storm surge, and overland flow, which could give rise to cascading effects that can worsen the situation, hence increasing the risk level further. The slide shows the GIS-based Common Operational Picture, COP, that was set up in Hong Kong by the government to enable the senior government officials to monitor the dynamic situation of multiple hazards in real time. This will greatly facilitate cross-departmental coordination and emergency response under disasters situations. In our experience, beefing up the technical standards to cater for extreme weather events is not the way to go. Instead, the most effective strategies for managing the risk of extreme rainfall events involves improving emergency management and enhancing community preparedness, resilience, and response. Now let's sum up. Past experience around the globe points to the conclusion that a well-designed and well-executed disaster risk management system is the most effective means in discharging one's due diligence and enhancing public safety. The key elements of a successful risk management system comprise people, data, policy, and technology. People in the present context refer to talents with the requisite technical and risk management skills, both of which need to be nurtured. In addition, risk managers should be especially mindful in guarding against ignorance, inertia, complacency, and the gambler's mentality of hope for the best. Otherwise, the price one has to pay can be tremendous. Let me end the presentation with this figure. The acute challenges faced by the risk manager are multifaceted. The landslide risk posed to the community is likely to increase due to a variety of factors, as highlighted in this figure, which include population increase, urbanization, illegal site formation works, unauthorized settlements, slope deterioration, and climate change. A reactive approach to tackling landslide problems will be more expensive and more damaging to the community as compared with a proactive systems approach. All in all, it's a daunting task for the risk manager and the profession. The challenges call for the implementation of best-in-class practice and judicious application of advanced technology and innovations. Thank you very much for your kind attention.